Good day everyone. Today we are going to do sums in definite integrals using substitution method. We'll tell you what changes you will have in that and what is the point you have to concentrate in it. Just let me tell you one thing in general. This is my blog address. Actually in this blog I have given chapters and chapter wise lessons in detail with text as well as audio. You can just visit my blog. I have given this blog address in the description also. So you can learn, especially the first volume, few chapters I have finished already and I will be posting further. So you can see this blog also. Okay, now let me write this sum. I is equal to integral 0 to 1 tan inverse x by 1 plus x squared dx. You consider this sum. I is equal to integral 0 to 1 tan inverse x by 1 plus x squared dx. When you see this sum itself, you will do tan inverse x, the differentiation is 1 by 1 plus x squared. So immediately you will see that when you see the terms. So here this sum has to be done using substitution method. So now let me write tan inverse x is equal to t, right? When I substitute tan inverse x as t, the next step will be differentiation. So you will write 1 by 1 plus x squared dx, that will be equal to dt. Then in this definite integral, one more step you have to write. The limits 0 and 1 or for the variable x. Now we have introduced a new variable t. So you have to now convert the limits of x to limits of t. That is very important. So now I am going to write changing limits. Okay. When I change the limits, when my x is equal to 0, my t will be tan inverse 0, which is also 0. Then my upper limit is 1. When my x is 1, t is equal to tan inverse 1, which is equal to pi by 4. Okay. So now substitute, differentiate, change the limits. Now let us come. Now our I will be equal to, now we are going to write the integration sum in terms of t and dt. So now the limits also I will write 0 to pi by 4, right? This is the limit with respect to t. Then this tan inverse x, that will become t. This 1 by 1 plus x squared dx, that will become dt. So within integral you will get t dt. So once you integrate it, you will be getting t squared by 2. Put a square bracket, write the lower limit, write the upper limit. So now take 1 by 2 common out. Then this t squared. So first substitute the upper limit, pi by 4 the whole square. Then the lower limit is 0, you will get 0. So you will be getting 1 by 2 into pi squared by 16. So your answer will be pi squared by 32. So just remember the 3 steps: substitution, differentiation and then changing the limits. Now we will see one sum which is entirely different from this. Even though I am going to use the method of substitution, later on you will have so many steps to do. So let us see that sum now. Okay. So now you consider the sum. I is equal to integral 1 to 2 e power 2x into 1 by x minus 1 by 2x squared dx. Okay. So I is equal to integral 1 to 2 e power 2x into 1 by x minus 1 by 2x squared dx. Whenever you see some e power x and then within bracket 2 terms, immediately you should remember one formula, that is integral e power x into f of x plus f dash of x dx, that will be equal to e power x f of x then plus c, of course, when it's a indefinite integral. So this formula you should remember. So now here straight away we won't be able to find the f of x and f dash of x. It won't fit into that. Not only that, e power you should have only x. You cannot have any other thing. 2x and all you cannot have. So I have to do a substitution here. So first I have to adopt substitution. So here this 2x I want to be a single variable. So I will write now 2x is equal to t. This is the substitution I am making. When 2x is t, you know, 2 dx is equal to dt, or dx will be dt by 2. Okay? Then I have some x also. So what will I do for x? X will be t by 2. So substitute 2x as t to make this term as e power and one single variable, and then you find for dx. Then this x also I need to substitute, I have taken. Then what is the next one? Changing the limits. Okay. So you have to remember these in the order. Changing limits. Now what is the lower limit of x? X is equal to 1. So your t will be 2x. So that will be 2. When x is equal to 2, t will be 4. So you got the new limits of t now, right? So now let me write my I is equal to integral 2 to 4. These are the limits of t. This e power 2x will now become e power t. Have this bracket. 1 by, what is x? X is t by 2 minus 1 by 2 into t by 2 the whole square. Close the bracket. Then dx is dt by 2. Okay. So now we have substituted everything and we have converted this sum in terms of t and dt. So first what I am going to do is, I will write this is integral 2 to 4 e power t. Okay. This one, the t by 2, when you reciprocate, you will be getting it 2 by t minus, here this is t squared by 4, 1, 2 will get cut. So you will be getting 2 by t square into dt by 2. Now the 2 in the numerator you can take common and you can cut it with this 2. Okay. So now you will be getting integral 2 to 4 e power t. Okay. This 2 and that 2 goes. I will be getting 1 by t minus 1 by t square dt. Now this is of the proper format. We have come in that. If you see, if this you take it as f of t, because it is not x, I will write now. Now my f of t is 1 by t. My f dash of t will be minus 1 by t square. So now this is of the format integral e power t into f of t plus f dash of t dt. So now the answer will be e power t into f of t. That will be the answer now. So using that, I will now write it is e power t into f of t is 1 by t. Okay. Then put the square bracket. Now write the limits, that is 2 to 4. So now you have got actually e power t by t. First let me substitute the upper limit, e power 4 by 4 minus substitute the lower limit, e power 2 by 2. You can actually leave it like that, or you can take that 4 as the LCM. You will be getting e power 4 minus 2e square. Okay. So in this sum actually, first you are substituting, because you are not straight away able to use this formula. After you substitute and do the simplification, you are getting in that format. You get some f of t, you get some f dash of t, then you use that formula, then you substitute the limits. Hope you are clear with these two sums, which will tell you how to deal with sums using substitution.